Today we're going to be talking about section 9.5, which is about adding and subtracting fractions, and then also something called complex fractions. Yesterday we talked about multiplying and dividing, and when we multiply and divide fractions, we can factor them and look for what matches to cancel. When we add and subtract fractions with variables in them, just like when we add and subtract fractions that just have numbers, what do we need to be able to add and subtract them? A common denominator. So when you add or subtract fractions, you have to have the same denominator. So in these first couple of examples, we do. So then I want to think about a really common mistake that happens when I have variables in the problem. That's not so common when it's just numbers. But if I have like 2/5 plus 1/5, what do I get? 3/5, right? Not 3/10. Okay? So when we add and subtract fractions, we need the denominators to be the same, and then we just add up the tops, and that denominator stays the same, right? So usually with numbers, that's not such an issue, but once we bring x's into it, then students want to start adding up the denominators as well. We don't want to add our denominators, we just want to add our numerators, and let the denominators be that common denominator. So we're going to get 9 over 3x. And then reduce when possible. I can reduce the 9 and 3 to leave 3 over x. When we do a subtraction problem, my first thing I'm going to do is change it to adding a negative. I'm going to put that negative into the second numerator. It's not such a big deal here, but as we progress through and these problems get a little bit more complicated, it becomes very easy to lose that negative in the middle of the problem. So when we attach it to the number, it's easier to keep track of it. So I'm going to change every subtraction problem to just adding and then throw the negative into that second numerator. Now these denominators are the same. So our answer will have that denominator, and then I can add the numerators. And I can't do any canceling here, can't cross out x's or anything like that, because yesterday we talked about how when we want to cancel something, we would need to factor and look for whole groups that match. Questions? Okay, when we have a common denominator already, things aren't so bad. When we need to get a common denominator, that can be a little bit trickier. So before we jump into working with letters, let's just work again with how we find a common denominator in general with numbers. So if I wanted to do 1/6, and you don't have to write these down if you don't want to, they're not in your notes. But if I wanted to do 1/6 plus 3/24, what would my least common denominator be? 24. So I'm going to change both of the denominators to 24. The second one already was, so it wasn't really a change, so that gets to say exactly what it is. But when I change that first denominator, I have to change the numerator also. So I have to look at how did I change the denominator. So how did a 6 become a 24? Multiply by 4. So I need to make that same change on the top. And then I can add them up. Okay. Let's try. This actually isn't the problem I wanted it to be. Let's see. I was trying to come up with numbers before class quickly that would illustrate some different things I wanted to illustrate, and I just realized I had chosen a bad example. This is better. All right, so what is the least common denominator going to be? Got it, Travis. 150. The least common denominator is something that will have to be at least the same size as them, but probably bigger than the denominators, because both the denominators have to go into it. So when we say the word least, then people start to think it's going to be small. We want to find the smallest possible number that both of ours divide into, not that divide into them. So a common answer is 5, because 5 divides into them. but we want these to go into our denominators. So one strategy for finding the denominators is to just kind of take them and start trying to multiply maybe the bigger one by stuff until you get something the smaller one goes into. So 10 doesn't go into 75, but 75 times 2 is 150, and then that goes in there. And this works okay for numbers. Once we have letters in there, it's not going to work as great. So what we're going to think about when we're working with letters in our problem is factoring, or breaking down our denominators. So what I would want to do is say, well, what is 75 made up of? 75 is made up of 3 times 5 times 5. Okay. Breaking it down into its prime factors. So what divides into 75? Well, 3 times 25, and 25 is 5 times 5. Okay. Or another way of writing this would then be to say 3 times 5 squared. What goes into 10? 2 times 5. Our common denominator will have to represent everything that is represented in either denominator. So it's going to have to represent a 2, a 3, and now with those 5s, we need to select the biggest thing. Since this denominator is going to have to be bigger than the originals, we need to select the biggest possible, so the 5 squared is bigger than the 5. And if we multiply that out, 2 times 3 times 5 squared, that's 150. Okay. This isn't usually the way we think about it with numbers, but when we start putting letters into the problem, we're going to have to think about breaking it down into its factors and representing what each of those factors are in the common denominator. So once we have those common denominators, then we need to alter our numerators according to what changed. So to get from 75 to 150, we multiplied by 2, so I need to multiply the top by 2. To get from 10 to 150, I have to multiply by 15, so I need to multiply the top by 15, and then I can add those up and get 91 over 150. Let's try one more. Okay, I have no clue what 132 and 162 both go into. Okay, it could take a lot of guess and check to get to something that's going to work on these. So what we're going to do is think about breaking them down. So when I break them down, I grab a calculator and I say, okay, 132, it's definitely even. So 132 divided by 2 is 66. Okay, well 66 divides by 2 times 33. And 33 is 3 times 11. I keep breaking it down as much as I can. Okay. So 132 divided by 2, and then I divided that by 2. It's going to be 33, which is 3 times 11. Or I can write this as 2 squared times 3 times 11. Then I do the same thing for 162. So 162 divided by 2 is 81. And then I want to break down 81, which is 3 times 27 and 3 times 3. You may have seen somebody do it this way before with what we call a factor tree, where we keep on breaking it down until we get to all prime numbers. So that's 2 times 3 to the third. Our least common denominator will need to represent every type of number that's here and the biggest of that type of number. So I've got 2's in both of them. I need the biggest 2, so I need 2 squared. Yes?
Isn't 3 times 3 9?
Yes.
Is this 3
Thank
times
you.
3 is 3?
Yep. So 3 times 3 is 9. And I need one more 3 times 3, so I actually need a 3 to the fourth. Thank you. So I need my biggest type of 2, which is a 2 squared. I need my biggest type of 3, which is now a 3 to the fourth. And I need the 11. So our denominator is going to be 2 squared times 3 to the fourth times 11. Our least common denominator is going to be 3,564. It would have taken me a long time to guess and check my way to that. Okay, so to find a common denominator, what we're going to do is break it down into what multiplies to make that denominator, and then we need to take the biggest of every type of thing represented. So the biggest type of 2, 2 squared, the biggest type of 3, 3 to the 4th, and the biggest type of 11, which is just 11. Okay? And then we would alter our numerators to match. Okay? So, to find the least common denominator, we're going to factor the denominators and take the biggest type of every factor. 6x squared doesn't factor. It's just one thing. Nothing I can do about that. Second denominator, I can factor though. What's in common in that denominator? 4x. When I take a 4x out, it's going to leave an x minus 3. So then what I want to do is think about what types of factors are present in this problem. We have number factors, the 6 and the 4. Okay. We have x factors, which would be the x and the x squared. And we have x minus 3 factors. Okay. And x is different than an x minus 3 because like yesterday we talked about when we cancel, canceling an x minus 3 is different than canceling just an x. Right? We would be canceling a whole group there. So when we think about our factors, we want to represent any number coefficients that are there. So that's like our 6 and 4. Any kind of letter coefficients, any powers of x's, x squareds, x cubes, that type of thing. And then any groups that are present. Okay? So for the number, what is the smallest thing that 6 and 4 both go into? 24. Okay? So for the number part, just find your common denominator the way that you found that before, the way that you're used to thinking about how to find that. Ooh, 24. Actually, it's smaller than that. That's a common denominator, but it's not the smallest one. That's the smallest thing they both go into. 12. For x's, we need to take the biggest type of x that's there. So we've got x squareds, or we have x's. X squareds are bigger, so we need to take an x squared. For x minus 3's, the first one doesn't have any, the second one has 1, so 1 is the most that we have anywhere. So those things are going to make our common denominator. So our common denominator is going to be 12 x squared x minus 3.
How do you get the x squared?
From the powers of x's that are present in each of them. So the first one has an x squared and the second one has an x. And we need to take the biggest power of each type of factor. So we're going to take the x squared because that's more than just the x. All right, so other questions on finding the common denominator? Then, just like when we're working with numbers, when we change our denominator, we need to change our numerator to match it. What we're going to do is carry down the old numerators, and then we're going to multiply by anything that showed up in the bottom that wasn't there before. So the bottom used to have a 6, now it has a 12. So what do I need to do to account for that? I need to multiply by 2. Since 6 multiplied by 2 to make the 12, I need to multiply the top by 2 as well. The bottom had an x squared, now it has an x squared. So that didn't change, and I don't need to account for that. The bottom did not have an x minus 3, and now it does, so I need to account for that by multiplying that in. When you're done with this, you should be able to cancel out and reduce and end up right back where you started. You don't want to because then you're going around in circles, but I could cancel these x minus 3's, I could reduce the 2 and the 12 and make a 6, and we would be right back at the beginning, and that's a good thing. We don't want to actually do it, but we can double check that that happens, that we haven't actually changed the value of the fraction. For the second one, we had a 4, now we have a 12. So what did we do? Multiply by 3. We had an x, now we have an x squared. So what do I need to do? Multiply by x. I had an x minus 3, I have an x minus 3. Nothing changed there. So our numerators are now, this is really a 10, and I'm going to distribute that through. So I get 10x minus 30 plus 3x squared. And I'm going to put that all over that common denominator.
Should you reduce the 3 and the 12?
We can't because it's part of an addition. So if we're going to do any canceling here, we would need to try to factor that thing, and I don't think it factors. Okay. So you do not need to factor your numerator out, and you don't need to distribute your denominator out. You can just both kind of let them rest where they are. Okay, so let's try another one. First thing I'm going to do on this one, since it's a subtraction problem, is change it to plus and put that negative into that second numerator. Otherwise, I find for myself, I tend to lose that little negative, and then it's attached to a number, I keep track of it better. Then to find a common denominator, we need to factor the denominators that are there. So for this first one, what multiplies to 4, that adds to 4? 2 and 2. The second one is a special form of perfect squares. So we factor as plus the perfect square and minus the perfect square. So then our types of factors. We have x plus 2's, and we have x minus 2's that show up in our denominators. How many x plus 2's does the first one have?
2.
How many x plus 2's does the second one have?
1.
So how many x plus 2's am I going to need in my denominator? 2. We don't have to accumulate them, so I don't need 3 of them. I need the most that any of the single denominators has. So the first one has 2 of them, the second one has 1 of them, I need 2 of them. Okay? I need the most that's already there. You don't need to accumulate them. So I need 2 of them, or I can write that as squared. How many x minus 2's am I going to need? 1. I don't have any in the first one, but I do have 1 in the second one, so I need 1 of them. Okay? You don't need to accumulate them. You need the most that's present in any single denominator. So I'm going to have x plus 2 squared and an x minus 2 as my common denominator. Then I bring down the old numerators, and I'm going to group up that x plus 1. And then I want to look at what changed. So in the original, how many x plus 2's did I have?
2.
And how many do I have now?
2.
So nothing changed. But I now have an x minus 2 that I didn't used to have, so I need to bring that in. In the second denominator, I used to have 1x plus 2, and now I have 2x plus 2's, so I need to bring in an x plus 2. I used to have 1x minus 2, I still have 1x minus 2, so that didn't change, and we don't need to do anything about that. Questions so far? Okay, now we need to do some foiling and distributing in our numerators here. So in that first one I need to FOIL. It's going to give me x squared minus 2x plus 1x minus 2. And in the second one I need to distribute, and this is where I find that it's really helpful to have attached that negative to the 2 because I need to distribute a negative 2, not just a 2. Okay? That's why I always change my subtraction problems to having the negative with that second numerator, because otherwise when you distribute it gets lost. So we need to distribute the negative 2 gives negative 2x minus 4. And that whole thing is over the least common denominator. I tend to get a little bit lazy in the middle of my work and I get sick of writing it over and over, so then I just start saying least common denominator. And then in my final answer I'll bring it back in. So when you combine my terms on the top here, I've got an x squared. For x's, I have minus 2 plus 1 minus another 2. So I have minus 3 x's. And for my constants, I have minus 6. And that's going to go over that least common denominator.
Why don't we FOIL the denominator?
We could, but it won't do anything for us to help us simplify it all. So we just leave it. So we just leave the top unfactored and we leave the bottom factored, just as switching either one of them won't help us. All right, first step, factor our denominators. 3x cubed is just one thing, so there's nothing to do with that. In the second denominator, what is in common?
3x squared.
3x squared. So that's going to leave then a 2x plus 1. If your fractions can be reduced before finding your least common denominator, it may be helpful. It's not always helpful, but it never hurts, and sometimes it is very helpful. So once I have them factored, I always look to see if anything can be reduced out of here. So is there anything that matches on the top and bottom of that?
2x and x.
One of those x's, right? So I can take it out, and I have just a 1 left on top and just a plain x left on bottom instead of an x squared. Sometimes it's helpful in finding a better common denominator. Sometimes it's not, but it never hurts to reduce at the beginning. So then I want to look at my types of factors. So I've got numbers, 3 and 3. I've got x's, the x cubed and the x. And I've got a 2x plus 1 group. So what kind of a coefficient am I going to need for this least common denominator? What kind of number?
Six.
So what are the numbers in the two denominators? 3. They're both 3, so they already match. So we don't need to do anything to that. Okay, the 3's already match. How many x's am I going to need? How many does the first denominator have? 3. How many does the second denominator have?
1.
1. So how many am I going to need?
3.
3. We don't need to accumulate and have 4. We just need the most that either one of them has. And how many 2x plus 1s am I going to need?
Just one.
Just 1. First one doesn't have any, the second one has 1, so we just need one of those. So our denominator is going to be 3x cubed, 2x plus 1. Bring the old numerators down. And then look at what changed in the denominators. So there was a 3, there is a 3. There was an x cubed, there is an x cubed. 2x plus 1, that's new. So it needs to go on the top. For the second one, there was a 3, there is a 3. There was an x, and now there's an x cubed. So what do I need? X squared. There was a 2x plus 1, there is a 2x plus 1, so that didn't change. So then I need to distribute in my numerators. So I get 8x plus 4, and the other one plus x squared, and that's all over that least common denominator. Questions? We are going to stop with examples here today. We're leaving one of the addition and subtraction problems and the complex fraction problems for Monday. But if you, so no homework will be due Monday. If you wanted to get some of it out of the way though, you can do through number 36 with what we have learned so far.